So we started this unit talking about why bonds occur between atoms, why atoms form bonds with one another. We said that bonds form because of or based on an attraction between the protons of one atom and the electrons of another. Now we want to focus on how those bonds occur. And in order to do that, we're going to take a look at two of the most common types of bonds and two of the most common types of compounds. The first of which we'll talk about is ionic. The biggest thing you need to understand about an ionic compound or an ionic bond is it involves the transfer of electrons from one atom or polyatomic ion to another. Now, when we say transfer, that means there is a loss by one species and a gain by the other. So something loses an electron and something gains an electron. And there are four basic ways this can happen. The first of which is when a metal loses an electron to a nonmetal. Remember last unit we said that metals are the lovable losers on the periodic table. They like to get rid of their valence electrons. They have very low electronegativities. Whereas nonmetals are sort of bullies when it comes to electrons, and they like to take other elements' electrons. They have very high electronegativities. So when you combine a metal and a nonmetal, you're going to get a spontaneous transfer of electrons from the metal to the nonmetal. In this case, sodium will lose its only valence electron to chlorine, and what you'll end up forming is a positive sodium ion and a negative chloride ion that has that one additional valence electron. Because of the fact that there has been a transfer of electrons from sodium to the chlorine, again, the sodium becomes positive, the chloride becomes negative, opposites attract, and that's the basis for the bond. That's the reason they stick together. So the positive sodium snaps together with the negative chloride, forming what we call an ionic bond. And then you get a bunch of those together, and you end up with an ionic compound. The second scenario is when a metal combines with a polyatomic ion. Brand new word. Now, polyatomic ion we can break up into poly, which means many, atomic, atoms, and then ion. So what you end up with is a many atomed ion. Instead of being a single atom like sodium or chlorine, a polyatomic ion involves, in this case, 1, 2, 3 oxygens and a nitrogen for a total of 4 atoms. And that's where you get the term polyatomic, and since it's charged, ion. So we have, again, metals like to lose electrons. In this case, we're talking about the metal being our positive, the polyatomic ion being our negative. And just like the first scenario with a metal and a nonmetal, opposites attract. The two of these will form an ionic bond with one another based on that attraction. And then if we get many, many of those bonds, we end up forming an ionic compound. So the attraction between these oppositely charged particles is the ionic bond, and then we get many of them together, we end up with an ionic compound. The next scenario is when we take a polyatomic ion, in this case now it's positive, combine it with a nonmetal, which we've already said likes to become negative. Same idea, opposites attract, and an ionic bond is formed between, this is ammonium, and this guy over here is chloride. Okay, and the final or fourth scenario for creating an ionic bond is when we have a polyatomic ion that's positive bonding with another polyatomic ion that's negative. Again, the same rules apply. Opposites attract. And we have, in this case, ammonium nitrate. And those are the four ways that ionic bonds can occur.